Some people think glass is glass and that all sight windows are the same. But that can't be right, can it? Let's talk about the differences and why that matters to your facility. The right sight glass makes your life easy and safe. But just as with any engineering decision, material specs for the glass are just as important as the metal components of your process system. So you want to get the spec just right. First, what about the glass material? You've heard about different types here. Most people are familiar with one of the most common types, borosilicate glass. It was actually brought to market by Corning in the early 1900s. You've heard of it, I'm sure. It was called Pyrex. It was a great solution for cookware, and it turns out it was a great solution for demanding chemical, food and bev, and pharmaceutical processing plants too. What was Corning after? Just what was the problem placing regular glass in a high-temperature oven? I have a demo for you to explain that. Watch this video.
In this test by Consumer Reports, a borosilicate baking dish comes out of a hot oven and is placed on a wet countertop. No cracks. When the same test is performed with a baking dish made of soda-lime glass, watch out! The same conditions can occur during an external washdown of a hot process vessel. What kind of glass would you trust?
Ouch, you don't even want to think what that would be like in a sight glass in your plant. If you consider how exploding glass in a process application moves at 5,040 feet per second, that's a quality and safety problem for any critical process application. Even if the glass doesn't totally shatter, you can't have any cracks or breakage at all taking place to risk glass shards contaminating your batch. What makes this happen? Let's examine the engineering properties taking place here. First, let's understand how high temperature affects glass. You can see that at temperatures less than 300 degrees Fahrenheit, typical for a non-critical application, standard soda-lime glass may be used. If your application has higher temperatures, up to 500 degrees Fahrenheit, you need to be sure you're using only certified borosilicate glass. No pseudo-boro imitations that are actually just soda-lime masquerading behind a boro brand name. Next, consider whether your application will subject the sight glass to thermal shock, like we saw in that Consumer Reports video. If so, genuine borosilicate glass should be spec'd. That's because borosilicate glass has a considerably lower thermal coefficient of expansion than soda-lime glass, making borosilicate glass more resistant to sudden temperature changes. Any physics geeks out there? Sure, there's a formula for this. There's real science behind what I'm saying. Don't worry about writing this down. I'll show you where you can look this up later. There are other factors to consider: abrasion, corrosion, impact resistance. I have more on that in a minute. But here's what you need to remember. At higher temperatures and pressures, borosilicate glass will always outperform glass with any presence of soda-lime at every point on this chart. That kind of makes sense now. If soda-lime isn't safe enough to go into your oven, why should you risk your industrial process and people to a sight window with soda-lime? So now that you understand a little more about the differences between borosilicate, soda-lime, and other pseudo-boro copies out there, let's talk about the fused nature of a sight glass, how the glass fuses with the metal sight ring material around the window. Here you need to think about the difference between tensile strength and compressive strength. I've got something on that for you here. You can see that when you apply heat, the steel ring expands. At the same time, the glass melts and fuses with the steel. Then, as the steel cools, it contracts and compresses the glass, making it even stronger. So why does compressive strength matter? You know that glass breaks under tension, or when it flexes, but it won't shatter or fail if the compressive force is stronger than the tensile force. So how do you ensure you have the most compressive force possible? That goes back to what glass material you're using. Simply put, the best engineering performance you can find is borosilicate glass. You're safer choosing borosilicate glass because it contracts less than soda-lime, so you're preserving the maximum compressive strength. One more thing, let's cover impact tolerance. Some of these processes demand the very best performance from your sight glass, so you want to be sure it can withstand the pressure. Watch this test lab video. It puts a meta-glass sight glass under 20 times the pressure of a typical sight glass application, then drops a steel ball on it with 7 foot-pounds of force. I know it's crazy, nothing you'd come close to experiencing in your plant. Let's just watch what happens.
The seal gasket and meta-glass sight glass are positioned onto the base flange. A metal retaining ring and bolts hold the sight glass in place. A pneumatic pump is connected to the fixture via a high pressure tube. Pressure is increased to 870 psi. If the glass were to fail at this pressure, it would be extremely dangerous. Even more pressure. 3,300 psi. That's 20 times the pressure of a typical sight glass application. The Metaglass is leak tight, but will it survive impact at this extreme pressure? A 1 meter plastic tube will guide the steel projectile to the target. It strikes the glass like a hammer. Did the sight glass survive? 7 foot-pounds of force were enough to chip the glass, but the gauge shows no leaks. With the pressure off, the nuts are removed and the test fixture is disassembled. Look at this remarkable sight glass. There are cracks on the surface, but the integrity of the glass has not been compromised. One side of the sight glass is chipped, but the product side is smooth and looks unscathed.
What do you see? No breakage, no pressure leakage. The integrity of the glass is proven under pressure. In fact, since it was introduced in the late 70s, there has never been a case where a Metaglass sight glass failed in a plant. Now, I'll be honest, there are some companies that like soda lime. Conventional soda lime glass is cheaper, and it works for less demanding applications. But you don't have to be an Einstein to know there's math and physics behind this that matters for high temperature, high pressure, and safe environments. Lowering your spec tolerances won't change that math. You can't trust your process and people to those who don't understand the science. That makes sense. Now, maybe you want to read up on this. At LJ Star, we're committed to providing the world's #1 selling sight glass, Metaglass, to even the most demanding applications. Certified, safe, and proven. Read why at ljstar.com and click the Resources tab. You'll see a lot of white papers and videos on what we've covered here. You can also get information about all of our process observation technologies that complement Metaglass. Hygienic fittings, visual flow indicators, LED lights even for explosive environments, cameras, magnetic level gauges. At LJ Star, you'll look better.